Let's talk about how to find the x and y components of a vector. There are four basic steps. Step number one is we draw the vector in standard position. Standard position means that the positive x-axis is the initial side of the angle. And we rotate through angle theta, where counterclockwise angles are positive, to place the vector in the correct quadrant. The second quadrant begins with the positive y-axis, which is 90 degrees, and then goes to the negative x-axis, which is 180 degrees. The third quadrant begins with the negative x-axis and goes to the negative y-axis, which is 270 degrees. And then all the way back around is 360 degrees, back to the positive x-axis. In this case, we see that vector A is in the second quadrant. Step two, complete the right triangle with the polar magnitude, always being positive, being the hypotenuse of what's called the reference right triangle. The other two sides of the reference right triangle are the x and the y components, as depicted here. Step three, find the reference angle theta ref. Reference angle is the acute angle between the vector and the positive or the negative x-axis, as appropriate. In this case, with a second quadrant angle, we can see that theta ref is this angle right here. To find theta ref for this particular case, we would say 180 degrees minus theta, where theta is the angle for the vector itself. Step four, use trig functions to find the x and y components of the vector. Since the cosine of an angle is the adjacent side over the hypotenuse, we use cosine of theta ref, a sub x, over the hypotenuse is the polar magnitude. Solving for a sub x, we get plus or minus, where that must be manually prefixed, plus or minus polar magnitude of the vector times the cosine of theta ref. In this particular case, we have a second quadrant vector, which means the x component is out the negative x-axis. Since the sine of an angle is the opposite of the hypotenuse, in this case the sine of theta ref, the opposite side is a sub y, the y component. The hypotenuse, once again, is a polar magnitude. Solving for a sub y, we once again get plus or minus polar magnitude times the sine of theta ref. In this case, for a second quadrant vector, a sub y is parallel to the positive y-axis, which is the positive y direction. The negative y direction is in the direction of the negative y-axis. Let's do an example. Demonstration problem 2. Find the x and y components of vector B. Magnitude is 74 meters. Angle is 296 degrees, placing it in the fourth quadrant. Step 1. Write the vector in standard position. Initial side is the positive x-axis. Terminal side is the vector. Step 2. Complete the reference right triangle, whose hypotenuse is a polar magnitude, in this case 74 meters, and whose other two sides are the x components, b sub x in this case, and y component, b sub y. Step 3, find the reference angle. Reference angle is the angle between the vector and the positive or negative x-axis, whichever is the closest, so as to make it an acute angle. In this case, that's a positive x-axis. Here we have theta ref is 360 degrees minus 296 degrees, or 64 degrees. Step 4, use the trig functions to find the x components and y components of vector B, b sub x, and b sub y. Cosine of theta ref, cosine is the adjacent over the hypotenuse. The adjacent is b sub x, the x component. The hypotenuse is polar magnitude. Cosine of theta ref is the magnitude of b sub x over the magnitude of b. Here, that's the cosine of 64 degrees is magnitude of b sub x over 74 meters. Therefore, solving for b sub x is plus or minus, where you must manually prefix the SIGN, magnitude of vector B times the cosine of 64 degrees. Here that's positive because we can see that b sub x is along the positive x-axis. That is the positive direction for the x-axis. Plus 74 meters times the cosine of 64 degrees. That gives us 32.4 meters. Now note that we will be using these vector components in future calculations. Here, 74 meters is only two significant figures. That means our final answer will have to be rounded to two significant figures. Therefore, to not propagate round-off error, we must carry at least one extra significant figure. So here we round this to 32.4 meters. If this was a final step, we would have to round to only 32 meters. But we will be using these vector components for future calculations. Sine of theta ref. Now the sine is the opposite over the hypotenuse. B sub y is the opposite side of this reference right triangle and angle theta ref. So sine of theta ref is the magnitude of b sub y over the magnitude of b. Here that becomes the sine of 64 degrees is magnitude of b sub y over 74 meters. Therefore, b sub y is plus or minus magnitude of b sine of theta ref. Here we see that b sub y is parallel to the negative y-axis, and so that is the negative y direction. We must choose the negative sign here. What we get is minus 74 meters, the sine of 64 degrees, and to three significant figures, that's minus 66.5 meters. Now it is your turn to work some example problems.